Hello friends, welcome to Susan and John MathTube. In this video, we're going to learn how to solve wave equation and heat equation specific problems using the technique we learned in lesson number 4. So do not watch the video if you do not have the notes that you prepared from lesson number 4. So let's start. So read the first question. A rod of length L has its ends kept at zero temperature. So I can see a heat equation. So immediately I'm writing, let the equation be, or the given equation is, and again I'm going to write the conditions. Can you see? U0t, because there are two things, x and t in the final equation. And x means the initial point of the rod, and L means the end of the rod because the rod has length L. So basically the rod starts at 0 and ends at L from the derivation. And they have given one more thing, initially the temperature. So can you see, they have given the initial condition which we will apply a little bit later. So u x comma 0 is equal to pi a sine pi x by L. Now look at this. Since the word heat equation, or since I can feel it is a heat equation, I'm not going for the long process. So step number 1, I'm going to assume let the solution be. So look at this. We have a word problem. The word problem is converted into the conditions and equations. Now I'm going to go directly to the last step. Let the required solution be. I'm going to pretend as if I know the solution. Sigma, come on, pause the video, try to write. It's a challenge because this is exactly what we learned in lesson number 4. So the answer will be an sine n pi x divided by L multiplied by e to the power minus n square pi square by L square into t. So I hope you still remember heat equation means there will be decay process, and since there is decay process there will be negative exponential distribution. So it's a combination. Okay, now look at this. What should we do next? First, assume the solution because it's a heat equation. Let this be the solution. The next thing to do is you apply the initial condition. So applying initial condition is very simple. I'm going to write given u x comma 0. That means I have to plug in t equal to 0 and plug everything into this equation. And what is u x comma 0? That is equal to sigma an sine n pi x divided by L multiplied by 1, because e power 0, can you see the t factor here? That t becomes 0 and e power 0 becomes 1. Now I'll plug in the initial condition on the left side because it's given the initial value is pi a sine pi x divided by L equal to sigma an sine n pi x by L. Students who watched the last video till the last will understand this problem is going to be super easy now. Can you see, according to the condition, this is not a random condition, it is given in terms of sine. And in such problem, all you have to do is you have to look at the value of n, the node. And I can see that n is 1. So that means I don't have to waste my time calculating the Fourier coefficients and all. I'll just write a1 is equal to pi into a. If you did not understand this step, it means you did not watch the last video till the last. Okay, and I'm going to write a1 equal to pi a because I can see 1. And I'll write an equal to 0 for every other value, means a2, a3, a4, etc, etc. And that's it. We have already solved it. So I got the value of an. Now all I have to do is I have to plug it back into the solution. So this is the solution and I'll plug it back here. Can you see there is a sigma which starts from 1 to infinity. So can you see when you expand this, we will get a1 sine 1 pi x by L e power minus 1 square pi square by L square into t plus a2 sine 2 pi x by L e power minus 2 square pi square by L square into t plus a3 plus a4 etc etc. But I don't care because all the an values are 0 bigger than 2. So I'm going to get u x comma t is equal to a1 sine pi x by L e to the power minus pi square by L square into t, and the value of a1 is pi a. So my final solution is u xt is equal to pi a sine pi x by L into e power minus pi square by L square into t. I hope you understood. So once more I'll repeat. We are doing problems in which it is specifically given or a hint is given. We have a wave equation or heat equation. And in such problems, you don't have to waste time using separation of variable method. Instead, you should be very good with what I taught you in lesson number 4. That is the main part which we will use to solve every problem here. And sometimes you'll be given awesome conditions which involve sine or cosine, which will give you advantage. Just like this problem, plug it back, that's it. So now let's go for the next question. So you can read, it's a long question. A tightly stretched string. Okay, this is a wave. Okay, it's also clearly given the equation also. And we can see 0 to L. So the wave is supposed to form between 0 and L. And they have given initial condition, the boundary conditions, and the velocity condition, etc. etc. So I can smell this is going to be long because it is not in terms of sine. Okay, so let's start. So since it is a wave equation, look at this. Since it is a wave equation, I'm going to write. No, you're going to write. So pause the video, write the answer over here. And in case you don't know what's the previous video, sigma, come on, tell me, sigma an cos n pi ct divided by L plus bn sine n pi ct divided by L, the whole multiplied by sine n pi x by L. Don't watch these videos like a movie. I want you to keep a paper and a pen, and I want you to scribble along with me. Okay, so this is step number 1. So we pretend as if we know the final solution, but we have to find an and bn using the conditions. So I'm going back. I can see the initial condition. So ux0 is equal to, a condition is given. So I'm going to apply that. So I'm going to find ux0. And we talked about it in the last video. So cos 0 will become 1, sine 0 will vanish. So we get an sine n pi x by L. Now the condition is Lx minus x square, because the value of ux0 is given, is equal to sigma n equal to 1 to infinity. If you want, you can keep an sine n pi x by L. Now look at this. This is exactly our Fourier series, Fourier sine series. And I want the coefficient. Don't forget, we are looking for an and bn. In the last problem, things were so easy because the condition itself was in sine. But here, for an, you have to apply the Fourier coefficient formula. 2 divided by L, integral 0 to L, because the length of the string, it's L here, and the function Lx minus x squared multiplied by sine n pi x by L. Those who have watched Fourier series will understand we have to apply the trick, Bernoulli's integration trick, because we have polynomial multiplied by sine. And there are 3 types of Fourier problems that they keep on asking: polynomial, and then exponential, and trigonometric. Anyway, this comes under medium level classification. So time for integration. So I'm going to get an equal to 2 by L, and I'm going to put a big bracket. And it'll be nice if you know Fourier, pause the video, try it, and multiplied by the integration will be, I'll put a big bracket, minus L by n pi cos n pi x by L, close the bracket, 0 to L, minus, you have to differentiate this. I hope you remember Bernoulli's rule. If not, I'll write it here. Integral uv equal to u and integration of v minus u dash, again integrate that part, plus again differentiate, again integrate till the polynomial will vanish. Can you see the polynomial is of degree 2? It is going to vanish in 1, 2, third step, and after that it will be gone. Okay, now the next term, differentiate this. So L minus 2x and integrate this stuff, and don't mess with plus or minus. We will adjust that in the next step. So minus L square by n square pi square, because integration of cos is positive, so that negative will stay, and sine n pi x by L, close the bracket, 0 to L, and then again plus minus 2, and again it will become plus because integration of sine is negative, L cube by n cube pi cube cos n pi x by L, 0 to L. And once more, I will give you a warning. In Fourier, I gave you the warning, don't write too much. Do everything in your brain. The more you write, the more mess it will become. Okay, if you want, you can keep the constants outside. Anyway, I cannot waste more time because in exam we have only 3 hours. Okay, so 2 divided by L. Come on, look at this. We are going to have an advantage. If I plug in the upper limit, I can see I'll get L squared minus L squared, gone, 0. And when I plug in the lower limit, I will get 0 minus 0. Now I don't care. So 0 minus 0, that's gone. 0 multiplied by some finite number, minus. Now I will plug in the upper limit, but here I'm not going to get advantage, but I can already see there is an advantage here. Can you see sine n pi? Sine n pi will be 0 because at every multiple of pi, every like what you call 1 into pi, 2 into pi, 3 into pi, it's going to vanish. And then the lower limit will give sine 0. So that's gone. So we are going to get again 0 minus 0. And now this is the most important term. So I'm going to write the constant minus 2, and let's plug in the upper limit. So we will get L cube by n cube into pi cube, and can you see cos n pi. Once more, my advice is don't write too much when you solve Fourier. Just keep the stuff in your mind and you have to be very good with the values. So cos n pi, that is minus 1 the whole power n, and then minus, when we put the lower limit, I think I'll keep this much constant outside. So when we put the lower limit, we'll get cos 0, that is 1. Okay, that's it. So an will be 2 by L, and then there is a minus over here. So again multiply by 2, and L cube by n cube into pi cube into minus 1 the whole power n minus 1. Those who worked out this step by yourself, comment below. Let me see how many of you know Fourier properly. Anyway, this minus, I hate minus, so I use the property minus a minus b is b minus a. So an equal to 4, and this L is going to get cancelled. L square by n cube into pi cube multiplied by 1 minus minus 1 the whole power n. That's it. So we got an. Now we have to find bn. Where is bn? Okay, here. And for bn, I'm going to apply the velocity condition. So an is ready. Now let's go for bn. Okay, now I'm going to apply the velocity condition. I hope you saw the derivative given. So let's differentiate this with respect to t first. And those who have memorized the formula which I gave in the last video can apply directly. Anyway, I told you in that video, I love derivation. It takes just 1 minute. So differentiate this. And when you differentiate, you can see n pi c by l will come common because we are differentiating partially with respect to t. And then this cos is going to become minus sine. So an sine n pi c t by l, and then plus bn cos n pi ct by l multiplied by sine n pi x by l. It's partial differentiation, so this stuff is a constant and you are differentiating with respect to t. Now the initial condition is given, so I'm going to put t equal to 0 because it's clearly given x comma 0. The derivative at x comma 0 is 0. Now this will become sigma. Come on, what happens when we plug in 0? Sine will vanish, cos will become 1, and this n pi c by l will stay. And bn sine n pi x by l. If you didn't understand this, watch the last video. That is a critical video. Okay, now it's given this is going to be 0. I love that initial condition. N pi c by l multiplied by bn sine n pi x by l. Now, come on. I'm going to do one drama, but if you want, you can write bn equal to 0. Now look at this. I'm going to apply Fourier. So n pi c by l into bn equal to integral 0 to l. Come on, what is the function here? 0 multiplied by sine n pi x by l. So integration of 0, which is a definite integral, will give you 0. That means n pi c by l into bn equal to 0, so which gives bn equal to 0. That's it, we solved it. So we got an to be something which looks weird, and we also got the bn value, and I'll plug everything into the original equation. What's the original equation? Now I'll plug it back. So u x comma t equal to sigma, I'll copy the an value, 4 l square by n cube pi square 1 minus minus on the whole power n cos n pi ct by l, and bn is super cool, so this part is going to vanish, sine n pi x divided by l. Now one advice, if you want you can stop it here, you'll get full mark, but I want you to understand one very important point. This number is a very special number. If you plug in the value 1, if you plug in n equal to 1, it will become 1 minus minus 1, which is equal to 2. So the number will become 8. If you plug in n equal to 2, it will vanish. And if you plug in n equal to 3, again 2. N equal to 4, vanish. So in some books, what they do is, whenever we get 1 minus minus on the whole power n, they will write sigma n equal to 1 to infinity, and they will write a word n is odd, or it will be specifically given use only odd numbers or n odd etc., and write 8 l square by n cube pi square cos n pi ct by l multiplied by sine n pi x by l. Now if they do not ask specifically, no need to do this step, but in some problems they will specifically ask you to solve like this or approve that question. Anyway, I'll be back with more problems from past paper in the next video. So till then, my friends, bye.